Hello, welcome back to Mr. Miles Maths. This is our third and final video on set theory. I'm sure you'll be pleased to hear. If you haven't looked at the other two videos already, I would certainly have a look at them. They have all the different concepts and examples and run-throughs of different questions. This is purely based on some past papers the questions have been pulled from on the new GCSE spec. So hopefully it'll give you a bit of an idea whether or not you've picked up the concepts that have been taught in the previous two lessons. I'll pause the video, in fact you can pause the video, on your devices. Have a go at the question. Want to copy it out, then you can do, and then I will run through the answer each time. So it should get more difficult as you kind of go through this, but let's have a little look through this. So question 1. So if you want to pause the video now, have a look, have a go. That'll be a good way of approaching this. So this says the numbers 1 to 14 are shown on the Venn diagram. So the first thing to note is that these are individual elements on this diagram. So the numbers 1 and 3 and 2 and 6 and 4 and 12, they're individual members or elements of the ones that I've highlighted there are of the set B. So this is not showing the number of things in the set, these are the actual values and elements themselves. So let's have a little look through. So the members of A intersection B. Intersection is where the sets meet. So these are members of both A and B, things that are common to A and B. And on our Venn diagram, that will be where they overlap. So here's 4 elements there, 2, 4, 6, and 12. So they are the 4 members of that set A intersection B. Things that are in both the set A and the set B, they're both enclosed by A and by B as well. Common to both sets. Notice how I write individual elements down. I could, if I want to, put curly brackets around this, but because I'm just asked to list the members, I don't need to do that. If I'm defining a set, I should do that. If you're ever in doubt, then just put them in anyway, and you're going to get the marks for it. Part B is B dash. So B dash, the dash means complement of a set, and the complement of a set is those things that are not in the set B. So all I need to do is look through my diagram now and look for anything that is outside the circle that B represents. So the 8 is outside B, 14 and 10. 2, 4, 6 and 12 are all inside B because they're inside the circle, so 1 and 3. And the other ones are 9, 13, 11, 7 and 5. They're all the ones outside of the set B or not in the set B. Again, I'll open up my curly bracket. Not necessary for this, but it will, it saves you getting it wrong if you do have to put it in. And then just list the numbers. You can put them in any order you want. Ascending order is fine, but it doesn't have to be as long as they're correct and they're in there. So I'll go for ascending order. So we're going to have 5, 7, 8, 9, 10, 11, 13, and 14. And just a quick double check, I have 1, 2, 3, 4, 5, 6, 7, 8 in my set. So hopefully there are 8 things outside of B, and there are 1, 2, 3, 4, 5, 6, 7, 8 things highlighted outside of B. So that's just the complement, those things that are not in B. And then finally, a number is picked at random from the numbers in the Venn diagram. So we're considering the whole diagram here. The probability that the number is in set A, but it is not in set B. So we want to look at things that are in A, but not in B. So we're talking about the whole diagram. So those that are in A and not in B are the 8, the 10, and the 14. So there are 3 numbers, or 3 members, 3 elements that are in set A but not in B. And in total, there are those 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's the numbers 1 to 14. 14 in total. So the probability of selecting something that's not in B but is in A is those 3 numbers, 8, 14, and 10. They're my 3 numbers out of a total of 14. Oops, sorry. So I can represent that as a probability like this. So it's 3 and 14. Don't need to write a decimal, don't need to write a percentage. 3 over 14 is a nice, neat answer as a fraction. So that's question 1 done. I'll scroll down to question 2, give you a chance to have a little look at it. So there's 3 parts to this, A, B, and C. There they all are. Have a look at those 3. Pause the video, have a go, and then come back to see my answer. So the first thing they've defined here is the universal set. In question 1, that's the big rectangle around the outside of our box. I probably should have mentioned that. In this, they've actually defining the set separately. There's no Venn diagram here, but it's the same idea. So that epsilon, this curly E thing, means the universal set. This is all the numbers possible in the question. And in this case, this is 1 to 10 inclusive. So 11 and 12, they are numbers, yes, but in this question, we ignore them because they're not part of the universal set. A is the set 2, 3, 5, and 7. So there's 4 things in there. And B is the set 4, 6, 8, and 10. Also 4 things in there. And we need to explain why A intersection B is equal to the empty set. So A intersection B is where the sets overlap, where elements are common. And if you look at A and B, you can see that 2 is not in both, 3, 5, 7, none of those numbers are in both those sets. So all you have to say here is that there are no elements or members, you can pick either of those words, that are common to both A and B. There is no overlap, there's nothing common, and therefore their intersection has no elements in, and that means it is the empty set. Okay, part B. So just above part B it says X, and if you remember that little E there before the epsilon, this means X is a member. So this thing here just means is a member. So they're saying X is a member of the universal set, so X is part of the question, and X is not in A or B. So remember the little line through the E. So this bit, that just means is not a member, because it's got the membership with a line crossed through it. So this means X cannot be in A or B. So I'm looking for an element that isn't in A and isn't in B either. Okay, it's got to dodge both those sets effectively. So I've got 1 to 10 to pick from. And I don't want, and if you want to get a pencil and do this, you could do, I can't have 2, 3, 5, or 7, because then the X would be in A. And I can't have 4, 6, 8, and 10, because then X would be in the set B, and therefore X should be in the union in some way. So therefore X must be just whatever is left over, which is the number 1 or the number 9, because they're in neither A nor B. And if X is not a member, that's what this bit here means, of the union of A and B, then it can't be in A or B. And these two elements are not in A or B. And then lastly, set C is such that A union B union C is the universal set. So that means these 3 sets make up everything. A intersection C is 2, and B and not C is 4, 6, and 10. If it helps you to draw a little Venn diagram out here, you might want to do that. I might do that in a second. You might be able to just think through this logically and come up with the answer yourself without the Venn diagram. So A union B union C is the universal set. That doesn't really help us. It just tells us that C is going to have numbers between 1 to 10 in it, and this includes all the numbers in the question. A intersection C, though, this is a good place to intersections are quite good. So that means A and C, they overlap, and they overlap with 2. So therefore C must have the element 2 in it. Because if it's in the intersection, it's got to be in A. We can see it at the top there. So it is in A, and it has to be in C as well. So we must take it as C. But it also means that C can't have 3, 5, and 7 in. Because A has 3, 5, and 7 in, and if A has 2, 3, 5, and 7, if the intersection doesn't have 3, 5, and 7 in, then C can't have those 3 numbers in. If the intersection only has 2, it's the only common elements to A and C. 2 is the only element that is common to both sets, and 2 therefore is in C. Now the next bit is a little bit more complicated. So we've got B and not C is 4, 6, and 10. So when we've got B combined with those things not in C, we've got 4, 6, and 10. And again, it might be helpful to draw a Venn diagram here. This is a little bit more confusing. But we want B and not C being 4, 6, and 10. So this means not C because it's an intersection. So that means C can't have 4, 6, and 10. Because B and not C does have 4, 6, and 10 in it. So we will ignore 4, 6, and 10, and we'll ignore 3, 5, and 7. So that should leave us with all the other elements. We're going to have 1 and 2, definitely. We can't have 3, 4, 5, 6, or 7. We can have 8, we can have 9, and we can't have 10. So B and not C, 4, 6, and 10, 4, 6, and 10 come from B, but the other one come from there. So let's have a look at some Venn diagram. It might make it a bit easier for us. So we've got a universal set. So A, B, and C are all in there. We know that A and C have an intersection because 2 is in there. So that's A and C have an intersection of 2, but 3, 5 and 7 are only in A and not in C. We have B intersection not C being 4, 6 and 10. So we know B is completely separate from A, but it might have some overlap with C. So B would be here. So B and not C has 4, 6 and 10. So 4, 6 and 10 are, and 8 in fact, are in here. 4, 6 and 10 cannot be in C because they're not in the intersection of B intersection C complement. And that leaves us with 1 and 9 here, which leaves us with 1, 2, 8, 9. This is a little bit more confusing. You just kind of think and try and visualize this as best you can. The intersections are useful. They can also be tricky when you've not got something. So B and not C, 4, 6 and 10. That means where B doesn't meet C, 4, 6 and 10, and they're definitely outside of A because they're not in A. It's a little bit trickier actually, that one. So these would be your members of the set C, 1, 2, 8 and 9. And if you want to, for completeness, I could copy that down into here. Okay, question 3. Again, this is drawing a Venn diagram. You can pause the video, write it out and have a go if you want. Okay, so universal set is defined as 1 to 12 inclusive. So all the numbers in the question will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. A is the odd numbers. So if you'd like to do this, you might want to write out that A equals the odd numbers from 1 to 12. So 1, 3, 5, 7, 9 and 11. A intersection B we've got written out. So there is an intersection and A union B is there as well. So let's draw 2 sets, one for A. And if I copy this, 1 for B must be inside the universal set. I'll just draw another one. And again, remember, it doesn't matter about the size of these things. So we'll have A and B, they're the only 2 sets in the question. A is going to have all the odd numbers, so all the odd numbers are going to be placed inside of that. I think I've accidentally duplicated something here. Sorry, my mistakes. And so yeah, we've got there's definitely an intersection because A union B is, A intersection B is 1 and 3, so 1 and 3 are in here. That's where they meet. So that means 5, 7, 9 and 11 must just be in A and not in B, otherwise they'd be in the intersection as well. And A union B has got all these other elements in. So that means we know that the odd numbers can be taken from A, so anything else must be taken from B. So we've got 1, 3, 5, 7, 9 and 11. So they're all kind of ticked off, 1, 3, 5, 7, 9, 11. So that leaves us with 2, 4, 6 and 12. And they must have all come from B to make it into the union, because they've not come from A, because we know that A is just the odd numbers. So anything that's not odd there must have come from B. The intersection is 1 and 3. And I'm just going to make sure that any numbers that aren't in A or B at all sit on the outside. So 1 is taken, 2 is taken, 3 and 4 are taken. So is 5, so is 6, so is 7. But 8 is in neither set, so I'll pull 8 out here. 9 is taken, 10 is in neither set, so I'll have to pull the 10 out. 11 and 12 are there in the question. So we can narrow it down to what's left. And that's your answer to question 3. Again, new question, question 4. I've definitely duplicated something dodgy here. Okay, so this time, question 4, let me draw a line across. Says the universal set is the positive integers less than 20. If it helps, you might want to write out all those numbers, but you should just be able to visualize it, but it won't take you long to do that, and I'll do it for completeness. (15, 16). So that'd be my universal set. Now, if you remember from my earlier videos, this notation here means A is the set of elements X. The colon in both of these just means such that. So this is x such that x is less than 12. So that means A is just the numbers in the universal set which are less than 12. So that'll be 1 to 11. Okay, it's strictly less than 12 because it's got the strict inequality here. It's not got the equal to bit like like part B will have, or set B. So x is less than 12, strictly less than 12. So A will be the numbers from 1 to 11. B is the set of elements x such that x lies between 7 and 16 with including 7. So B will be 7, 8, 9, 10, all the way up to 16. But we can't include 16 because of the strict inequality. So the colon means such that, and the strictness of the inequality means I don't have 16 here. I've left it out. But the equal to inequality here means I can take the 7 there. And then from here, I just have to put all this information into practice. So we'll have A intersection B is where A and B meet. So same kind of questions, you can see how often it pops up, so make sure you know what it means. So these are things that are common to A and B. So I want to go through and just look at anything that's common to both these sets. So you can see that 7 is common, 8, 9, 10, and 11. So that will be my A intersection B set. So 7, 8, 9, 10, 11. Will be that. Hopefully that's okay. And then the next part of this, let me rub them out. Pick the correct pen. Day for a lot of mistakes, but making mistakes is fine, so long as you correct them and learn from them. Okay, so all ready to go. So C is a set such that C and then this funny symbol. So hopefully remember from last time or from previous videos, this means that C is a subset of A. And that means C is a smaller part of A. So C is entirely enclosed within A. That means A might have a few more elements, but C has to all be members of A. So that means C is a smaller part of this set here. So the numbers 1 to 11. It says that NC equals 3. And again, hopefully you remember, this just means the number of members or the number of elements in the set C is equal to 3. So C has just got 3 things in it. Other bit of information is that C are all even numbers. So we can't have any odd. So we need 3 things and we can't take anything that's odd, and they've got to be a smaller part of A. So they've got to be within 1 to 11. So if I just copy A in here, you can see. So it's got to be a smaller part of that set. And I've got to take even numbers. So the even numbers here are 2, 4, 6, 8, and 10. So for the answer to this, I can have, and this is why it says one possible set, because there's more than one answer here. You need a combination of any 3 of those even numbers. So we could just have 2, 4, and 6. You could have something like 2, 4, and 8, or 2, 4, and 10, or 4, 6, and 10. Any 3 of those even numbers that are a part of A, you can take, because C is a subset of A, means that C is a smaller part of A. So C would be equal to this, for example. But there are other answers you could have. Okay, 2 more questions. So a similar kind of notation here. This is the universal set. So integers of x such that x is between 10 and 25 inclusive. Again, if I wanted to write this out, I'll do it on the left, then I could. So this would be 10 to 25, and they're whole numbers because that says integers. (21, 22, 23, 24, and 25. So that'd be my universal set. So they're the only numbers I can consider in this question. Very, very similar to the last one, this A, x such that x is less than 18. So A will have all these numbers in here that are less than 18. Just so happens that I've managed to split that, didn't even mean to do that. So A will be these numbers because they've got to be part of the universal set, and we're told that x must be less than 18. And then we're also told that b is x such that x lies between 13 inclusive and 22 strictly. So b must be equal to, I can have 13 because of that little equal to sign in the inequality. So I can have 13 right the way up to 22 because of this, but I can't have 22. So you have 13, 14, 15, 16, 17, 18, 19, 20, and 21. So either you write that all out at the start. You can see it takes me a little bit of time to write it out, but if it helps you to see what's going on, it's not necessarily a bad idea. It'd help if I made it a bit neater. It's right on the edge of my screen. There we go. Or if you just want to think about this as you address the question, then that's absolutely fine as well. So the number of things in A, this is what this means. So the number of elements in A, so I just count them up in A. So 10, 11, 12, 13, 14, 15, 16, and 17. There's 8 things there. So that will just be 8. We're not asked for the individual elements, it's the number of things in the set. A union B complement. So we want all those things that are in A or B, but not in that set. So first thing we're going to look at is A union B. So that means I can take everything from A or everything from B. So all of A, so 10 to 17. So that'll be A, but I can also add in anything from B that I haven't included yet. So I've already got 13 to 17, but I can have 18 to 21 as well. Because the union, I can have anything from both sets. So 17, then we can have 18, 19, 20, and 21. So that's A union B, and therefore A union B complement is everything not in that set. So I'm going to take all the things that are not in there. So we're going from 10 to 25 on the universal set, but we can't have 10 to 21 effectively. So that just leaves us with 22, 23, 24, and 25. That's the complement of A union B. So A union B means A or B, so I can take everything in A or B. But then the complement means not in that, but it has to remain in that universal set. And then A complement and B. So this means not, remember this means not in A. And it's got to be in B. So not in A means I can't take these because they're all in A. So I'm not allowed to have those, but it's got to be in B as well. So if I look at that, this rules out kind of this part of B, but that would leave me with 18, 19, 20, and 21, which are definitely in B. Here they are. But you can see just by looking above, they are not in A. And then some more subsets here. So C is a subset of A, and C is also a subset of B, and there are 5 things within C. So this is what this means. C is a subset of A, so it's a smaller part of A. C is a subset of B, so it's a smaller part of B. So C has to lie entirely within A and B. So C will be made up from numbers from here and here. So kind of like the, let me get rid of that. So it's got to be a part of A and it's got to be a smaller part of B. And there's 5 things. This means the number of things in C is equal to 5. So we want a smaller part of C and a smaller part of A. So I can't have 10, 11, and 12 in because C would be a subset of A then, but it wouldn't be a subset of B because I don't have 10, 11, and 12 in B. Remember, it's got to be a smaller part of the set, which leaves me with 13, 14, 15, 16, and 17 as my 5 elements. So all makes sense, I hope. So there's 5 things there, and for similar reasons, C is a smaller part of A, so therefore I cannot have 18, 19, and 20, because if C had that, yes, it would be a subset of B, but if it had any of those in, it wouldn't be a smaller part or a subset of A, because A does not have those elements in. So they're my 5 elements in that. And then the last question, which is kind of a three-way kind of Venn diagram. So year 11 students study one of geography, history, and religious studies. There are 65 students in total. All parts of the Venn diagram add up to 65. And then we've got various things that are part of this. So if you want to pause the video and have a go, then please do. There's a couple of questions here on this as well. Okay, so let's have a look through. So when you do these questions, you want to focus on the intersection that has everything in the start. What you've got to be careful of is something like this statement here, which I've highlighted, 21 study geography and history. It doesn't tell us enough. It tells us that 21 study geography and history, but it doesn't say whether or not they study the third subject, in this case, religious studies as well. So we've got to be careful with how we think about this. So the best way of doing this is always to try and think about those who do, and they've actually put it in a nice order for you, that there's 15 who study all 3. So if I start from the middle and work my way out, and if I don't know what the middle is, it's quite a good way is to call it X at the start. You'll get questions sometimes like that. So 15 study all 3. Because then I can then go through and say, well, if 21 study geography and history, that's this part of the diagram here. Well, if these 15 are already studying geography and history, so that means there must just be the 6 left over. So 21 minus the 15 to give me 6. The 6 left over to make a total here of 21 who study geography and history, but 15 of those 21 do all 3, which means 6 just do geography and history. If it says just, then I'd put the 6, then I'd put it in here, but it's not. It's 21 studying geography and history in some capacity. So we don't know how they're allocated, but because 15 of them study all 3, it means that there's 6 left over. And the same kind of idea here. So 16 study geography and RS. Well, if 16 study geography and RS, that's this part of the diagram here with the 15. But there's 15 of them do all 3. So that leaves me with just 1 in here. Then my 16 doing geography and RS. 1 does just geography and RS, the other 15 do history as well. And we can build up our diagram in this way. We know that 30 study geography. So that means the total inside geography, sorry, that's poor. Total inside geography, which is here, must be 30. So if I do 30 take away these 3, which is 30 take away 21, which is 9. There'll be 9 in here, and that gives us our, that's wrong, isn't it? 22, sorry, it should be 8. So that will give us this part of the diagram here. And then we use the next bit of information. So 18 study only RS. So this means this part of the diagram must be 18 because only 18 people do RS and nothing else. But then there are 37 who study RS in total. So that means the total of R must equal 37, which means we can find this last little bit here. So if we do 37, take these, and I'll try and get it right this time. So that's 34, so this will be 3 in there. And are there any other? Yeah, they must study. So there's one other bit of information we've not used. This is why you've got to read the question carefully. All students must study, so must study at least 1. So that means 65 will be the total of everything within the set. They can't be outside any of these 3 sets because they must study at least one of these subjects. So if I just do 65, I can take away all the different parts of the set or the Venn diagram, and that should give me my value in here. So let's total this up. So 65 can have 51, I think. So we're going to have 14 people left in here. And that completes our Venn diagram. So start with the middle, start with the intersection, and move your way upwards from there. And then a student in year 11 who studies both history and RS is chosen at random. So we're told that they study both history and RS. So history and RS is in this part of the diagram. So we're told that. So we're only considering those 18 students that are in this part of the diagram. So work out the probability that the student does not study geography. So that means we don't want this one. So we know that there's 18 who study history and religious studies. So we're picking from 18 because we're told that at the start. We're told that they study those, and then we're choosing them. So we have a condition on this already. and we want to know what the probability of them not studying geography. Well, there's 3 people out of the 18, and I can simplify that to 1/6. So there's 1/6 chance that they do not study geography. 3 out of those 18 people is 1/6. And that's it. There's a few trickier concepts in here. It is quite a tricky thing to explain when you can't have the opportunity to ask for questions, but hopefully it's cleared things up and you've had a good go at these questions. And it's nice to see you. Thank you for coming back. If you like the video, then please like. If you want to subscribe as well, because there's lots more videos coming, or make sure you check the other set theory videos in particular, then that's fine. And that'll be good. And if you've got any requests for any particular videos, then I will try to make videos on those topics as well. Thank you. See you.